Good morning, class 9. Today, in our subject science, in the class 9, the second chapter, that is force and motion. It is also the longer chapter, and today I teach you about the Newton's law of motion here. And before teaching this Newton's law of motion, you have also studied about the rest and motion. Means there are different types of bodies in this whole universe are only found in two states, that is the rest and the motion. Rest means those bodies which do not change their position with respect of the surrounding are in the rest, but those bodies which change their position with respect of their surrounding, then we say that the bodies are in the motion. Means body changes their position which are in the motion, body does not change its position which are not in motion. On different topics, after studying this, Newton studied and made the law, propounded the law on the basis of the rest and motion, which is called Newton's law of motion. Here Newton made a law on the basis of the state of body that is rest or motion. This one is the Newton made a law on the basis of the state of body that is rest or motion is called Newton's law of motion. Newton's law of motion. This one is. It means when the bodies are in the motion, then after, in what way that body is in the motion in the straight line, which factor affect the bodies when these are in the motion. About this matter, this Newton's also made law. That law is called Newton's law of motion. He made three laws of the motion. Means there are three laws of motion. This one is. Means these three laws of the motion was made by Newton. That is also called the Newton's law of motion. And there are three laws of motion. Number one, that is the first law. First law of motion. The Newton's first law of motion. What does it mean? This Newton's experience or observed different types of bodies in this universe, and he found that bodies are only found in two states, either in the rest or in the motion. The body which are in the rest always regain the position of the rest. The body which are in the motion always regains their position of the motion, unless external force act on it. This is called the first law of motion, and here is the first law of motion. It states that this first law of motion states that the bodies which are in the rest or in motion, in uniform motion, they are continued in their continued in their state of rest or motion in a straight line unless external force acts on it. This is the Newton's first law of motion. Again, you read this. The first law of motion states that the bodies which are in the rest or in the uniform motion, they are continued in their state of rest or motion in a straight line unless external force acts on it. This law is called first law of motion. I give you example of this first law of motion here. There are many examples of this one. Here is. You can also give the example of this. Like here is one body. Look in my hand. Here is this. Suppose this body is in the table here. This body is kept here on the table like this. This is the body, and when this body is not disturbed by any external force here, this body always regains the position, and this body remains at the same place, here forever. It means there is no change in the bodies. Why this happened? Because of its properties. That is why it regains the position of the rest. Other way, if we throw the body like this here, any body is thrown from here. This body is here at A, and this body is thrown. Look now, this body is going on. Where it goes means continuously it is going on. It never stops. Means this is continuously in the motion. But here first case, a body in the rest. Second case, a body in the motion. This is moving body. Here is moving body. If the body is moving continuously, it moves continuously, never stop. If body is in the rest, it never goes in motion. This law is cleared by this example now. And about this matter, first law explain. Means here, when a body which are in the rest or uniform motion, they are continued in the rest or uniform motion unless external force act on it. Like here, this fan is in the rest now. Here, that fan means it always in the rest. If no any external force act on it. But when switch is on, you also know that this fan starts moving and come in the motion. If switch is not up and current present in the circuit, permanently that fan is moving. Other example of this, when we kick the ball, this ball is rolling on the ground. This ball will be in the motion and won't stop unless external force acts. But we know that after kicking the ball, it moves, and after traveling some distance, that ball comes in the rest. Why? You know that there is also external force acting on the body, like the gravity and friction. These two external force acting on the moving body, and after some time, that body comes in the rest. You are already familiar with this one. In this way, my dear student, you can also give many examples of this first law of motion here. Again, you listen now. This first law of motion states that when a body is in the rest or in motion, it is continued in its state of rest or motion unless any external force act on it. It is about the first law of motion. After this, I teach you second law of motion. Now we have Newton's second law of motion. After learning the Newton's first law of motion, you come to know about the Newton's second law of motion. Newton also did the different types of experiment and made, after doing the experiment, he also made the law. That law is called Newton's second law of motion. And according to this Newton's second law of motion, he also stated that the Newton's second law of motion states that the acceleration produced in a body is directly proportional to the force applied on the body. Here is the Newton's second law of motion states that the acceleration produced in a body is directly proportional to the force applied on the body and inversely proportional to the mass of the body. Here, this is the second law of motion. It means here, if there is more mass, acceleration produces less. If there is more force, acceleration produces less here. Here I also show you one example here. Here is one body and A. And when force applied on the body, this body A accelerates, means move towards like this in this direction. Means amount of force increases, acceleration increases. Here this A increases. When amount of force act on it decreases, this acceleration decreases. So it is also said that this acceleration is directly proportional to the force applied here on this activity. Again listen this. Here is one body. If force is applied on this body accelerates. If the amount of force acting on the body increases, means acceleration also increases. Means body moves more fastly. Why? Due to increase in the force applied. If applied force decreases here, means that body accelerates in less amount. In this way, we can say that this acceleration produced in a moving body is directly proportional to the force applied here. Then after second example on the same body here, that is body B. Here is this force applied on the body accelerates, but mass of the body is more here. This mass of the body is more, and also acceleration produced in that body is, it means more force is required here to accelerate due to its more mass. It means mass increases, acceleration decreases here. And if mass decreases, acceleration increases if amount of force is same here. It means this acceleration produced in this body is inversely proportional to the mass of that body. This means when mass increases, acceleration decreases. When mass decreases, acceleration increases. This is clear from this statement. Means Newton's second law of motion states that the acceleration produced in a body is directly proportional to the force applied on the body and inversely proportional to the mass of the body. In this way, you know about the Newton's second law of motion. In other words, it is also said that prove that F is equal to ma. After this, I teach you the other topics that prove that F is equal to ma under this topics. Means Newton's second law of motion. Then how can we prove that F is equal to ma? It is also very simple that prove that F is equal to ma. Means from Newton's second law of motion we can prove it, and here you also know that here the two bodies, here is at A and here is mass of the body m. When force applied on the body here, what happens? Body accelerate. Acceleration produced here. First case, here suppose a body having mass m is accelerated due to applied force on it. It means when force is applied here on this massive body A, this body accelerated, and this acceleration produced in the bodies here is, suppose a body having mass m is accelerated due to the applied force on it. Means the acceleration produced in the same body is directly proportional to the force applied. Here means amount of force applied increases, acceleration increases. Amount of force applied decreases, acceleration decreases. We can also write that is this acceleration A is directly proportional to the force applied. In this way, you have to also know this. Again, listen this. Suppose a body having mass m is accelerated due to the applied force on it. The acceleration produced in the same body is directly proportional to the force applied, that is A proportional F. A means here acceleration and F means force. Second case now, number 2 case. Here is body B. That same force is applied on it, but mass of the body is more here. This mass of the body is more. Then after, this body is also accelerated and acceleration produced. Means to accelerate more and more, means more force is applied on the body, even acceleration is less. Why it happened? Because of its mass. It means if mass increases, this force applied also increases, mass decreases, force applied decreases. It means when mass is more, acceleration produced in a body is less. And when mass is less, acceleration produced on a body is more. It means it is inversely proportional. That is, A is inversely proportional to the mass here. And here in first case, A is proportional to the M. this one, and here is this one. So after knowing the first case of this, we also know that and acceleration produced in a body is inversely proportional to the mass of the body. Here it means this acceleration produced in that body is inversely proportional to the mass of body. That is A proportional 1 by m. Here 1 by m. A proportional to 1 by m. Here this is the equation 2. The acceleration produced in a body is directly proportional to the force applied. Acceleration produced in a body, that is A inversely proportional to the mass of the body. We get here two equations. Now from equation 1 and 2. Now from equation 1 and 2, we get here A proportional F by m. In this way you can also write, or this F proportional ma. This is the equation 3. In this way you can also write. If you want to give the equation also, nothing happens. Or here the proportional sign, this sign. You can replace this sign here by giving the equal sign and adding constant later. Like this F is equal to K M A. This is the equation 4, where K is constant. Where K is constant. Just you know about this equation. 4F is equal to K M A. This one is, this F is equal to K M A. You have to find the value of this K. Here, if F is equal to 1 Newton, M is equal to 1 kg, and this A is equal to 1 meter per second, then from this equation 1 is equal to K into 1 into 1. Therefore, K is equal to 1. Here we know the value of the K. K is equal to 1 now. Is putting the value of K, putting the value of K in equation 4. Equation 4. In this equation, what is the value of K now? K is equal to 1. You know that. Or F is equal to 1 M into A, where K is equal to 1. Or this F is equal to Ma. Therefore, F is equal to Ma. In this way, you can also prove it. This is the Newton's second law of motion. And this Newton's second law of motion also depends on the two factors here. One is mass and other is the acceleration. If we say that acceleration produced in body depends on two factors, one is force and other is mass. In this way, you can prove it. Sometimes also ask that, prove that F is equal to ma, or prove that Newton's second law of motion. In this way, you can easily prove the Newton's second law of motion. After learning thus Newton's second law of motion, now you know about also here is a force, that is 1 Newton force. Means what is meant by 1 Newton force? Means the amount of force applied on a body of mass 1 kg. Means here unit mass. 1 kg means unit mass. The amount of force applied on a body of mass 1 kg to produce acceleration of 1 meter per second is called 1 Newton force. 1 Newton force here. We also know that this force is equal to mass into acceleration. This one, or this F is equal to m into a. Just we know that the amount of force applied on a body of mass 1 kg to produce acceleration of 1 meter per second here. So what is the mass of this body? 1 kg, and acceleration of this body is 1 meter per second. Therefore, 1 Newton force, 1 Newton force. This F is equal to 1 kg m by square. This one. This is about the 1 Newton force. This is also very simple. You can really understand about this matter. You can illustrate this. If we have any bodies here, this body has mass m is equal to how much? 1 kg mass. Yes. If force applied on the bodies, this force applied on this body of unit mass, accelerate means moves, produce the acceleration. How much acceleration is produced on that body? That is equal to 1 meter per second. If this much acceleration is produced in that moving body, then we say that this F is equal to 1 Newton force. This one is the 1 Newton force acting on the body. In this way, you understood about this matter. And after teaching this, I teach you about the Newton's third law of motion. You are also familiar with the Newton's third law of motion here. Means this Newton's third law of motion is also very important in our daily life. And here I teach you about, this is the last topic of the motion, Newton's third law of motion. Third law of motion. Simply we call it third law of motion, or in other words, we can also say that Newton's third law of motion. Listen now. In every activity or in our daily life, we see the different types of activities. And you take the ball now, you just strike the ball in the ground, you also see that that ball bounced. Means balls again comes up. If you give the one slap to other one and you ask that person what happened and you also feel what happened to you. It means here is two types of things. One is action and other is reaction here. Here is one body, this body is here. If we apply the force on this body, this one, this is the body now. If force applied on that body, what happened? This body also applied the force. Here, look the direction. Force is acting on the body, and this body also act the force on that body. Means force acting on the body, that is the action. Here is, and this body also act the force on it, that is reaction. Here is. In this way, we can say that this action and reaction. So Newton's third law also said that Newton's third law of motion states that to every action there is equal and opposite reaction. This one is Newton's third law of motion states that to every action there is equal and opposite reaction. You have seen the different types of activities. You have also seen the flying bird. When that bird is flying, at that time that birds also push their wings downward and backward. Means that air also push the birds upward and forward. Due to this, bird can easily fly in the air. Other example is if you go to the pond or river for taking bath and you start swimming. When you swim there in the water, you also just give the downward and backward force in water. Water also exerts that forward force in your body and you can easily swim in the water. This is also called action and reaction force. I also give you here. You also look here. You have seen the spring balance. This one is. This spring balance. Here the number now. Value. These two spring balance also connected each other. Another spring balance is here and contact like this one. In this way, here the two spring balance. The two person is just pulling each other to this spring balance. Spring balance A and spring balance B. You pull it, means that force is applying here. Look now, this one. This here is equal to 10 Newton of force is applied. In the same way, other person is also pulling like in that direction. This here is equal to 10 Newton. It means same reading is shown by the spring balance. Here, two persons are also pulling both the spring balance in one. Reading shown by the two spring balance. Here is 10 Newton, here 10 Newton. If few amount 5 Newton, 5, 15, 15, 50 Newton, 50 Newton, what does it mean? It means this person is just pulling it, that is action. Here is. If B, other person is pulling this, that is reaction. Here is. Here both action and reactions are the same. This activity also clarify the Newton's third law of motion. And I also give you the very good example of Newton's third law of motion that is in your home or you have a pen that you can also pull together each other, and if no one can pull it, then we can say that this action and reactions are also equal and opposite. But after teaching this one, I also suggest that in your home, dear student, whom you like too much, your mommy, daddy, brother, sister, anyone, you request him or her and say that, please you give me one slap in your cheek, there. After that, you ask your mom, your that relative person, brother, sister, uncle, aunties, father, mother, anyone, what happened to your hand? You will give the answer, pain in the hand. Means he or she gives you slap in your cheek here. You feel pain, but in place of you, who provide you that slap also feels the pain. What does it mean? That is the reaction. Means when just give the slap, we feel pain here, and who give the slap also feel the pain in his or her hand. It means here is also action and reaction. These action and reactions are always equal and opposite. In this way, you know about the Newton third law of motion. Other, you have also seen the boat in the river. While the boatman is boating with a stick, you know that force is always acting backward on the boat, and boat is going forward. Means there also just applying the force on the boat, on the stick, that is the action, and boat is going forward, means by pushing water, that is the reaction. So in every case, we know that there is action and reaction. This is the Newton's third law of motion. So today you know about the Newton's three laws of motion. First law of motion, second law of motion, and third law of motion. In short way, again I tell you, first law of motion means the bodies which are found in the universe are always found in two states. One is the rest and other is the motion. Means it gains the original position of rest or motion. This is the first law. Second law is the acceleration produced in a body is directly proportional to the force applied and inversely proportional to the mass of the body. And you have also proved that F is equal to ma from the second law. Then after here the last third law, this is here. It is very simple now. To every action there is equal and opposite reaction. Today you learn about this one, and in next class I will inform you with the new topics. Thank you very much.